Relationships are complicated in life and in data. You may have been surprised at something that seems so simple, a one-to-one relationship, could come with so many things to consider. For example, that EF Core must be able to identify a principal and a dependent in a one-to-one relationship, or that there are quite a few ways to map this relationship. And given that you can add configurations, even more possibilities if you're not depending on conventions. But the simplest mapping for EF Core to recognize a one-to-one is the one with the most clues: navigation properties on both ends and a foreign key in the dependent or child class. And that mapping comes along with some defaults. The child is always optional, the parent is required, and if you delete the parent, a cascade delete will also delete the child record. Fortunately, querying across the one-to-one uses the same patterns and syntax that you've already learned. But it was also fun to finally have a thread of relationships all the way from author to artist, so we could write a multi-level query to bring back a complete relationship. When it was time to join objects in one-to-one relationships, you learned that you really need to protect yourself against accidentally breaking the unique foreign key constraint, where you might try to join a cover to a book that already has a cover. And if EF Core is tracking all of the relevant objects, it will delete a cover to make way for a new one. And I shared with you my guidance based on a lot of experience about how important it is to know your tools and understand their behaviors. There are a lot of variations for the mappings and the behaviors, and my best advice is to try them out and understand what the behaviors are before implementing them in your applications. There have been a lot of tasks along the way that I've said can be more easily solved by just using raw SQL or a stored procedure in the database. Finally, in the next module, you'll learn about EF Core's capability of allowing you to use views, stored procedures, and other database objects that might already be in your database, or that you might want to create to solve some persistence problems more easily. Here again are some resources that I've mentioned in this module, or that I think you might find relevant. I'm Julie Lerman, and thanks again for watching Entity Framework Course 6 Fundamentals. So far, we've let EF Core generate all of the SQL for us. This module will focus on leveraging EF Core's ability to execute raw SQL and stored procedures, as well as map to database views so you can easily query your read-only data. EF Core does support working directly with a variety of database objects beyond just tables, as well as SQL statements that you can pass in directly. You can work with stored procedures and database views. You can map scalar functions, and thanks to yet another contribution from community member Paul Middleton, you can even map to table value functions. I won't be demonstrating mapping to scalar functions or TVFs, but I will leave a link to the documentation in the resources. There's another cool feature, which is also a little advanced for this Getting Started course. In the DB context, you can map an entity to a database query so that EF Core will always use that query instead of generating its own SQL. There'll be a link in the resources for this feature as well. You'll learn about using EF Core's ability to run queries using raw SQL or stored procedures, and still be able to capture the results into entities and track their state. You'll also learn how to use customized migrations to add stored procedures and views or any other database objects you need in the database. And you'll learn about using EF Core's keyless entities, which are read-only, and how we can use those to capture results when querying the database view that we created. And finally, we'll look at another way of executing raw SQL, which is to execute non-query commands on the database. And as an example, we'll use a stored procedure to easily delete database rows, something I've mentioned a few times already. So let's get started. EF Core lets you execute raw SQL for your queries in cases where you don't want to rely on EF Core to generate those queries for you. And you have the option of providing the whole query in your SQL or using it to call stored procedures. There are two methods that let you execute raw SQL queries against your defined DB sets. One of the methods is called from SQL raw, and the other is from SQL interpolated. And the reason we have two methods is because of the difference between how EF Core handles strings that are created in different manners. From SQL Raw and From SQL Interpolated are DB-set methods. So they give you more ways to retrieve entities where you can use existing assets in your database or create procedures in the database when you have a query to express that's just too complicated for a LINQ query, or perhaps LINQ is just creating a badly performing expression. It's important when using From SQL Raw to use parameters when doing things like filtering, so you don't have to worry about SQL injection attacks. For the first example, I'm using the context and authors DB set, and then appending From SQL Raw to that. And I'm passing in the most basic of SQL, select star from authors. And don't forget a LINQ execution method. I'm using two lists at the end of this. Now that exact SQL will get sent to the database. And there are my authors that were returned to the database and materialized by EF Core. And EF Core will track these as well, just like with any LINQ query. One of the requirements with using the From SQL methods on the DB set is that the SQL needs to return data whose structure matches the entity represented by the DB set. That means your query needs to return all of the scalar properties, no less and no more. So if MySQL only selected, for example, the name column, EF Core will throw an exception at runtime when it's trying to materialize author objects from the results. Additionally, because these are DB set methods, they can only be used for known entities. You can't use the raw SQL query to return a type that's not known by the DB context model. That also lines up with its ability to track whatever is returned. And keep in mind that if you are specifying the columns instead of doing select star, the SQL has to reflect the columns in the table, not the entity. So navigation properties like books, or if you're querying covers, then the author navigation property will also cause an exception to be thrown when EF Core tries to create those objects. You can append other LINQ methods onto the From SQL Raw method, as well as some of the DB-set iQueryable extension methods. For example, here I've appended include to also bring back the books for those authors. EF Core is able to bring back the books along with the authors. Interpolated strings are strings where you can integrate variables into a string without having to concatenate the string and the variables. With C#, that means you need a $sign in front of the string, and then the variables are wrapped in curly braces within the string. While you can certainly use From SQL Interpolated with on-the-fly SQL in your code, it's much more commonly used with stored procedures to supply their parameters. And I'll dig more deeply into From SQL Interpolated as we move further along this module.